are now live and recording. Alrighty, so let me come down here and grab WebEx, or WebWarp rather, whatever that is called. And over here. Okay, let me pop one over here. Okay, guys, so you can send me a text. Bill, I need a Lysol wipe to sanitize my phone because I have not had a chance underneath the kitchen sink, unless somebody didn't put them down there. It's the only thing I didn't get done from when I got home. Tim, do you know where the Lysol wipes are?
Nope, I couldn't find them.
Well, they were right back here.
Just grab one out of the truck.
It should be right there. Okay, anyway. Alrighty, guys, go ahead and send me a text, or whatever. Let's see here. Problem 11 on the review, please. Okay, let me bring up the review. Let me come in here. Reviews and keys. Bill, if you could move that drink and my lunch a little closer, I might be able to reach it. Thank you, sweetie. Thank you. And a napkin when you get a chance. Thanks. I appreciate it. I had asked Timothy for my white and red books also that were with these. They should be over there. Intro to statistics over there, white with some red writing. Thank you. I appreciate that. Okay, problem 11 says, okay, affirm. Let me go ahead and open up our notebook and we'll just insert this in. Thank you, Timothy. Appreciate it very much. Okay, don't laugh at the dot to dot. I tutor all ages, including kindergarten, okay, and third graders that aren't able to count. So now you know what's going on with that. It's a good way of teaching everybody how to count. Let's see, we're adding over here. And okay, let me think here. We're doing a study session, and today is April 13th, 2020. Here we go. And we're going to insert a screenshot if I can find this. Let me open this up in here. Okay, Tim? As long as you keep it close by, but it still hasn't been sanitized, so you don't need to touch it till we can get it. I can't, I'm sorry, I can't enter. Well, I'm sorry, I can't help with that right now. So. Okay, here we go, guys. Sorry about that. Oh, let me add paper, because you know if I don't add lots of paper, and let me change the view to notebook paper. Come on, there we go. Okay, I need to pay attention to who I'm talking to and who asked for that. It looked like maybe more than one person asked for this problem. Thank you. Once you're done, just wash your hands good and make sure and let it air dry for just a minute. If you don't mind wiping the surface of my book, because that's where I'd set my phone. Thank you. Okay, here we go. Oh, Timothy, I'm sorry. I also need that algebra book that I used behind to drop down on top of it. Oh, it's right here. I think I can reach it. I can get it. Is everything cleaned out behind my computer?
Yo.
There we go. Is it right there? Thank you. Okay, perfect. Now I've got a desk. Okay, somebody has a live mic, which is fine if you're talking to me. Okay, so let me come back to over here and see. Okay, so Kaylee asked, and Owen asked. Mallory, I don't have the second half available. We're about to make one of those problems available right now, though, and I will get the rest done. When is lunch? I don't know. I haven't had lunch yet, and I haven't eaten breakfast yet today. But my husband did make me a nice lunch, and it's sitting right beside me. So at some point, maybe when I'm not talking, I'll be able to take a bite or two. Okay, so a firm with, let me get up here. And again, students, if you have a question, feel free to make your mic live. Ask your question, and then you can mute again when it's appropriate. So a firm with the department store of Atlanta, Georgia has some stores located in the inner city and some stores located in the suburban shopping centers. In a study designed to learn about the different characteristics of inner city and suburban customer populations, a sample of 60 inner city customers and a sample of 80 suburban customers was taken. The data obtained for customer ages is below. So here's that right there. It says using a 96% confidence interval, estimate the difference between the mean ages of the two population of the customers. Okay, so this is a confidence interval. Are you okay? You need a finger? Okay. There you go, sweetie. I'm sorry. You can change the settings on that right now if you need me to help you with that. Let me know. Okay, so here we go. So we're looking for a 96. Oh, I love this question, by the way. I hope you all really understand this well for your exam. So here we go. Confidence interval, 96 percentile. We're doing the difference between mean ages. No, it should be, is it mean ages or is it proportions? Hold on, let me look at what it says. A firm with a department store in Atlanta, Georgia has some stores located in their inner cities and some stores located in the suburban shopping center. In a study designed to learn about the different characteristics of the inner city, we have a sample of 60 and 80 was taken to obtain the customer ages. Okay, so it is the mean age that we're looking for. So we're looking for the difference of MUs. And we're looking for the two sample size, sample standard deviation. Shoot. Guys, I put this one together, trying to throw together this, and I didn't proof it. So this one here, oh no, we're good. No, we're not good. Because it says sample standard deviation. You all don't have tables for 96 percentile. I thought I had this set up as a Z, and it's not. So that's why everybody's having problems with that. Is that probably the case for the people who asked? Yes, Lynn, you're welcome to come for lunch. Okay, so so I typed this up, and I tried to get this out quickly, and when I expedite, I grabbed from an old textbook, okay, and you kind of saw a little bit of the conversation when I sent out an email. I said things have changed over the years, okay? So it used to be when, back in the 90s, when some of these textbooks were put together, if your sample size was over 30, you would do a Z distribution, okay? That used to be the rule of thumb, was based on sample size. Now we base it off of whether you have the sample standard deviation or the population standard deviation, okay? So let's just change this one real quick. I'll make sure I send out an email so that let's turn this into a T. And I was really also wanting for you guys to be able to practice finding a Z for 96. That's also what I was looking for. So let's turn this one into a T, and let's change, in order to do that, all I have to do is change this right here from a 96. Let's just make it a 99 because I don't have a, we're just gonna make that a 99 because I know if I make it a 99%, that is in your T's. So once we change this to a 99, we're good. Is that gonna help everybody else out? Do you still need me to solve it, would be my question for the people who asked. If I change that to 99, are you good or not? Everybody's good? So my question is let me rephrase my question. Do you want me to continue solving this problem? Yes or no? Yes, okay, gotcha. Yes, I will. Here we go. Okay, so we're changing it to 99, and so let's write down all the information that we know. Because we have a sample standard deviation, okay, it's going to be a t-test. Because of that, it's going to be the t-distribution. And it's going to be the difference of your mean. So it's going to be population 1 minus population 2, and it's going to be a confidence interval at 99%. So let's gather the information that we know. We know that population 1 is the inner city, population 2 is the suburban. And we have our mean years is going to be 40 minus 35. That's going to be our point estimate. So if I said, what is our point estimate? That's going to be 40 minus 35, which is equal to 5 years. Is everybody good with that? Give a thumbs up, say yes, do something. I want to make sure, because on your test tomorrow, it will say, what is the point estimate, okay? Because the way I have to design your test is it's going to be, you're going to have one problem, and it's going to have several questions, and it's just going to walk you through the solving of it, okay? And pretty much, you know, one of the very first things it's going to ask is, what's the point estimate? The second thing I'm going to ask is it a Z or a T distribution, okay? Then I'm going to be asking, what is your critical value? So let's find the critical value. Remember, with our critical value, we're going to be looking for a T.99, and our degrees of freedom is going to be based on the smaller of the two sample sizes. So, oops, sample sizes is over here. So our smaller sample size is 60 versus 80, okay? So our degrees of freedom is going to be 59 degrees of freedom. And we may not have 59 on the tables that UWF gives us. So let's come in here and open those up real quick and look. So if we come in here, let's see, do we have 59? We don't. So when you don't have 59, you go to the next smaller one. So we have a 50. So for the degrees of freedom, not in the table, use the closest degrees of freedom that is smaller. So the key thing is that you have to go smaller. So if the appropriate degrees of freedom is 59, you see 59 isn't here. You don't go to 60, you go to 50 instead. Okay? So, and then we're going to be at 0.99 degree confidence, which is right here, the second to the last row. And we're going to be looking for 50, which looks to be that value right there. So it's going to be 2.678. Does everybody understand how I got 2.678? Yes, the chart, Blaine, is on the test. The very first problem, I'm not going to say that it's going to be convenient, okay? I'm hoping, I don't know if this is going to work or not. We have a fake student, if you want to call it that, in your Canvas, okay? It's just called test student. So I'm hoping that today I can log on as the test student so that I'm in the student view and I can experience taking your test in hopes of working out any kinks or problems before you guys take it tomorrow, okay? So that's my goal. I can't promise you that I'm going to be successful, but that's my goal. And the very first problem is a true, false, or yes, no question that says, do you understand that all tables and formulas that you need are in this first question, okay? So even though you may have to go down to question 20, because every single part is going to be numbered differently. So don't freak out because there's so many problems on there. If you look at this problem right here, let me bring it up. This problem right here, well, let's look at one of the other problems. This one right here, okay? So I have 1, 2, 3, 4, 5, 6, 7 parts right here of problem 10, okay? So each question like this is going to have 7, maybe even 9 parts to it, because I'm going to have to walk you through and let you answer everything, okay? I'm probably going to have to, I haven't gotten to the hypothesis yet, but I'm probably going to have to say, what is the null hypothesis? And let that be a question. The next question will be, what is the alternative hypothesis? It's going to be a step-by-step thing. So once you're in here, then you're going to have to go back out of problem, whatever problem you're on, go back up to problem one, look up your information, and then come back and use that information. I'm expecting you to have blank paper, okay? And I will advise you tonight, in my last email that I sent to you for preparation for tomorrow, how many blank pieces of paper I feel like you would need. And I'm expecting you to solve the questions on paper, and then input your answer, okay? That's what I'm looking for. And then within 15 minutes of you submitting your exam, I want you to take pictures using your cell phones or whatever camera media that you have. Take pictures of your work and email it to me right away. Don't text it. I need it emailed to me. And within 15 minutes. And then I can look at that email for partial credit and see if you went wrong. So since I'm talking to you guys, I haven't made the test, Marjorie, so I don't know yet. Will we be able to have our hard copy of the table? Jordan, so far that's a firm no. I have requested permission to let you guys use it. If it was up to me, you'd have an open notes, I just, because it's either you're going to pass a test or you're not, but it's not up to me. So right now the rules is no, you won't be able to have your own set of tables and formula sheets. Okay. So here we go, point estimate. So that's our point estimate, and then our formula. Let's go ahead and cut and paste our formula in because it's the difference of means. And that's going to be over here. And formula sheet is right here. And we're going to be on the third page of the formula sheet. And it's going to be the confidence interval for mu, and we're solving it as a t, so we're going to be using this right here, and this is going to be our formula right in here. So that's what we're going to go ahead and insert, and I did not write down our t, so I need to write down my critical value in just a second. So there's that. My critical value, let me go back and grab that in here. It's 2.678. So 2.678. Alrighty, so let's go ahead and calculate our E. Our E is going to be 2.678. Did you get all the groceries put away? Thank you, honey. And divide it by the variance for population 1. Remember, the sample standard deviation squared is just the variance. So for population 1, it's 9, and for population 2, it's 10. So it's going to be 9 squared divided by 60, I think. Yep. Divided by 60 plus 10 squared divided by 80, if I remember correctly. Yep, 80. And we're going to throw this in the calculator. And my calculator is going to look like this. And literally, I'm going to have you guys where you're working on this. And I don't normally like to ask for E, but since your homework is set up to ask for E, it does make it nice for calculating your confidence intervals. Oops. Please go back. So it's 2.678 multiplied by the square root of, now right here, make sure you put parentheses. I could go ahead and put 9 squared, but I know 9 squared is 81, so I'm just going to put in 81 divided by 60. I'm going to close parentheses, and I'm going to put plus. I'm going to open parentheses. And again, 10 squared is just 100, so go ahead and put that in. Divide it by 80. Close parentheses. You don't have to, but I like to come out from underneath that and then hit enter. So it's 4.318. Because your t-tables go to 3 decimal places, I'm going to go to 3 decimal places also. So it's 4.318. So 4.318. And that's going to be our E. So our confidence interval is literally the point estimate. So it's point estimate plus and minus e. That's all your confidence interval is. So your confidence interval is going to be 5 years plus or minus 4.318. And so when I subtract, I hear a lot of beeping. Did I make a mistake on something? Let's see here. Oh, where did I get 81? It's 9 squared because the formula is squared. And remember, you're more than welcome to unmute yourself if you have a question like that as I'm going through. So 9 squared is right here. It's our standard deviation squared, which is also called the variance. And I'm given the sample standard deviation right here. If I gave you the variance, I'm not going to. I normally would, but because we're not in person in classes, I'm not going to up the ante on your exam to that degree, okay? But normally on your exam, your third exam, instead of giving you your sample standard deviation, normally I would give you like your sample variance, because I want to make sure you guys understand the correlation between the standard deviation and the variance. By now you should know that. That will be on your final exam. So if you decide to take the final exam, you'll probably see that concept possibly on your final exam. So anyway, okay, so the formula says we need your sample standard deviation, which is 9 and 10. So that's where I got those 9 and 10, both of them squared, because that's what the formula says to do. Alrighty, so our confidence interval is 5 point, whatever, let's see here, it's 5 minus our prior answer, which is this right here. So it's going to be 0.682, so 0.682. And then I'm going to add 5 to it. And so it's going to be, or add the other number, which is 4.318. And that's 9.3. So 9.318. So this is our confidence interval. What's important to notice on this confidence interval is, does this confidence interval contain the number 0? Does this confidence interval contain the number 0? Anybody? Very good. It's important for you to notice that when a confidence interval does not contain the number 0, that means if I had done a hypothesis test at 99% confidence, I would have, if I was looking for like a difference, I would have detected a difference, okay? So just to kind of, whenever you're doing confidence intervals, okay, when you're looking at confidence intervals and it does not contain the number 0, chances are you're going to have a significant statistical hypothesis test, okay? So that reveals that there is a change, okay? So in this case, I would be able to say that population 1, the inner city, is older than the suburban people, okay, that shop at the store. So that would be the way you would be able to expect a difference like that to show up, where you actually do have a hypothesis test that shows that there is a significant statistical difference. Okay, so this right here is my final answer. Are there any questions on that particular final answer? Does everybody understand?
Why did you go to 50 when you did your critical value?
Okay, whoever just said that, say it one more time. My volume was down really low, so I could hardly hear you.
When you did your critical value and
Oh.
degree of freedom was 59, why did you go to 50 instead of 60?
I'll show you. Thank you for asking for that again. Okay, so and it says this right down here on your T-tables. Okay, at the very bottom it says, if the degrees of freedom is not in the table, use the closest degree of freedom that is smaller. So since I had 59, 60 is closer, but it's larger. So I have to go down to the smaller number. Is that good?
Okay, I didn't notice that. Thank you.
You're more than welcome. Any other questions? Anybody else have a question? No questions? Well, this test will be graded before the final exam. Oh, yes, yes. I have my work cut out for me because I have a lot of I've got to get Top Hat transferred over. I've got a few corrections in Top Hats for a few students. So today, so you're taking your test on the 14th. I'm not promising, okay? I'm on recording, so clearly understand, I'm not promising. My personal goal and objective is to have final grades out where you can look at them and know what your grade is by the 21st. I really want it done by the 19th, but my drop dead personal goal is the 21st. And so that's so hopefully by then I'll have all your grades finalized in the Canvas, and you will know exactly where you stand. How many decimals should we round our margin of error for the test? Typically 4, correct? Yes. Unless it's proportion, then 6. So Marjorie, did you hear that? Kimberly, yes, you're correct. You're welcome, Marjorie. So I'm at Alex. When there is a two-tail test, like on problem 10 on the review, do you always choose a positive statistic? No. Hold on, Alex. Let me bring up number 10 here. I think you said it was number 10. Yeah, number 10. Alex, do you have the test statistic right there where I can look at it? If not, I'll calculate through it. Oops, I went to the wrong room screen. There we go. It's 1.3. Okay, is it one tell or two tell? 2. And is it a t-test or z-test? Okay, Alex, if it were me, let me go double check the information you gave me. Two-tailed, okay. If it were me and I was on the test, remember that still crooked, going the other way. Anyway, there you go. If I'm looking for a p-value, right here is 1.3. That's my test statistic, but I have a two-tailed test. So because it's a two-tailed test, I must look at both areas under the curve in this area right in here. I need both because it's a two-tailed test for my p-value. So what I would do if it were me, because I know this is symmetrical, I know the area in here is the exact same amount that's in here, I would look up the negative 1.3 because that's the way your tables are set up for UWF. See, it gives you that part right over there. So I would look up negative 1.3. Negative 1.3 is 0.0968. It's this number right here, okay? So it's 968. So it's 968. So let me come in here and put in, so this is 0.968. 968. We have to add both of those areas together to get the p-value. So it's going to be 2 times 0.0968, and that is going to be equal to, grabbing my calculator, ooh, my calculator's funky, please. There we go. So it's 2 times 0.0968, and so that is equal to 0.1936. That is your p-value. And I would look up negative 1.30, because if I don't look up the negative, Alex, what I'm going to have to do is I'm going to have to come in here, and if I look up the positive, really what I have is this whole area right in here. Everything to the left of positive 1.3. So then I have to go 1 minus this whole area all the way through, including down in here, to find out that this area right here to the right is 0.0968. So why go to all that trouble when I can look up the negative and just know the area to the curve from negative infinity to negative 1.3. Does that help, Alex? Let me come back to you. And you're welcome, Alex. In the same, I'm going to tell you, it's the same thing for a one-tailed test. If I had a one-tailed test, and you don't have to do this, okay? If you're not comfortable doing it, don't do it. But if you have a one-tailed test, and let's say your test statistic was 1.3, and you needed the p-value, you could just look up negative 1.3, and that's going to give you that area that would be to the right, okay? Whatever's easiest for you to minimize confusion, minimize mistakes, I'm good with. Other questions? I'm going to grab one bite while I look for questions here. How do you tell if it's a T or a Z? Okay. You know what? I'm going to type because typing is faster for me. So how do I tell if it is a Z or a T? Okay. 1, if it is a proportion, it is a Z. Period. That's it. Okay. First thing. Okay. If it deals with proportions, it's a Z. Okay. Now, if it's not a proportion, assuming it's not a proportion, it has to do with means. Then what you're going to look at is, do you know sigma or do you know S? Okay. So do you know your population, standard deviation or your sample standard deviation? Okay. If population standard deviation, it is a Z. Excuse me. If sample standard deviation, it is a T. Okay. How do I know if I have a population standard deviation? If you see the words or phrase the population standard deviation is B. It is known that the standard deviation is. When you see the key phrases that you're going to look for to recognize that it's the population standard deviation. 1, you're going to see the phrase, the population standard deviation is, or you're going to see the phrase, it is known that the standard deviation is. If I know my standard deviation, then I know the population standard deviation, okay? So when you see the phrase, it is known that it is known that the standard deviation is whatever, that tells you you're looking at a population standard deviation. Let's go over for the next one. How do I know if I have a sample standard deviation? Okay. If you see the words or phrase A sample of size n, whatever n is, okay? It'll be a number, okay? It will be a number. A sample of size n gave the mean, again a number, and the standard deviation. Okay? So that tells you in one sentence, I found from sample size n, whatever that n is, it'll be a number in your problem, that you have the mean, that the sample gave the mean, or you yielded the mean, or calculated the mean. So you could have the word, gave, yield, that would be IE, yield, calculated. So it could be the word gave, yield, or calculated, right there, okay? So if I highlight that, Oop, that didn't do it. Okay, well, gave, and then gave, yield, calculated. So right there, those would be all part of it. And then the rest of it here is, let's see, our sample size of n gave that. Okay. I took a random sample of size n and found, that's another keyword, that the mean was and the standard deviation was, is, whatever, okay? So that's what you're looking for, is you've got to be able to read the English and decipher, are we talking about the standard deviation coming from past historical data? Oh, that would be the other thing. So it is known, or it is historically known, of course you're seeing the word known, that the standard deviation is, or it is known, again you're seeing the word it is known, from past years, or whatever the time frame may be, that the standard deviation is, deviation is. Okay, so let me grab that eraser, because I kind of keep that, I guess, a little bit. There we go. Alrighty. So did that help? Who am I speaking with here? Blaine, did that help? Good. Mallory, I'm going to do my best. Typically, this is a guideline. This is not a hard, fast rule. Typically, I go out of my way to make sure you know that it is a population standard deviation, okay? That's what I typically do. And so if it's not glaring at you that it is a population standard deviation, look at the words closely, because chances are it is going to be a sample standard deviation in that case. Does that help, Mallory? Okay. Okay, let's see here. I have a couple of questions. On the exam, when we were doing the questions and we show our work, did you mention earlier that we send them to you via email and not text? Yes, it's via email. Also, well, hold on. Yeah, you send me a copy of your work after you have submitted the exam. You can't do it during the exam. Also, since I have special accommodations, how much time do you have to take the test? Everybody else is being allowed 2 hours, so it will be whatever the multiple is of 2 hours. So if you, let's say if you have 1.5 times, then you would be allowed 3 hours. If you have 2 times the normal accommodations, then you would be allowed 4 hours. And everybody who has special accommodations, I think I know my students, but please send me an email today because I do have to put you in with the exam a little differently than other students.
I have one question about the like the formula sheet.
Yes.
I know you've covered it like a million times, but is it gonna be like listed in the same order as it in like same format as it's listed like in our notes, since we're used to studying from that and like doing our problems from that?
I don't understand
Like,
what you mean. It's going to be the exact, it's going to be this formula sheet right here.
Okay, it is. It's gonna be like the exact formula sheet.
It is the exact formula sheet. Yes, ma'am. All 4
Perfect.
pages.
Thank you so much.
You're welcome. The downside is, you know, I've given you permission to add little touches of notes on it. You're not going to have that. So make sure you're really familiar with your formula sheet. Okay? Other questions? Let me look at my cell phone also. See if anybody's texted me a question. Okay, let's see here. Okay, so that's a college algebra student. Could you go over p-values? So, Nathan, are you here today online? Can I do problem 12? Owen, I'm taking that means you are agreeing with number 12. Is that correct? Isabella, the tables are also going to all be embedded. Okay, great. So I'm going to jump over to Nathan because he asked a question via text, and then I'll come back to problem 12. So, and to answer Isabella's questions, yes, the tables, your Z tables, your T tables, as well as your formula sheet will all be in question 1. So you'll have to keep scrolling back up to find them, but they are all there, the exact ones from UWF that we have listed there. Okay, so p-values. Here we go. Oops. And Nathan, if you want to, you're welcome. If you want to unmute at some point in time to ask more specific questions, if I'm not quite answering what you're asking, please let me know. So p-values. We have a couple scenarios concerning p-values. So with a p-value, let's first just discuss Z tables, okay? That's the first thing I'm going to talk about is just Z tables. So let's say you need a p-value for a Z table. You have 2 scenarios. You have one, which is a one-tailed test. 2, it's a two-tailed test. Oops. Okay. And let me double check, guys, to make sure I'm recording. I'm sure I am, but I don't want to. Yeah, I am. Okay. There we go. Okay. So if we have a one-tailed test, under the one-tailed test, we have 2 options. We have option A. It can be a left-tailed test. And that looks like this right here. And we'll put our test statistic right here. So this will be our test statistic. And when we look for our p-value, if it's a left-tailed test, we're going to go from our test statistic to negative infinity, okay? For my exams, for exam 3, okay, I'm not making the final exam. Another instructor's taking and making the final exam. So this will be the last exam that I make that you will be taking. For my exams, if you have a left-tailed test and you calculated a p-value over here that's positive, you've made a mistake. Either it's not really a left-tailed test or you made a calculation error. Because for me, if you have a left-tailed test, you're going to have a negative test statistic, okay? So in that case, in order to find this area under here, I'm going to make up a value. I'm going to say that my test statistic is negative 2.31 for the example. Okay, so it's negative 2.31. And my p-value then is going to be actually my p-value is equal to the probability that z is less than negative 2.31. It's the area under the curve that meets that criteria. So in that case, we're going to look up negative 2.31 in our z tables. Negative 2.31. So negative 2.31. Right there is our value, negative 2.31. So the area under the curve is 0.0104. So 0.0104. So 0.104. So right here it is 0.0104. So that is our p-value. Again, this is based off your test statistic, not your critical z-value. Nathan, are you good with the very first part that we've done so far right here? Okay, so the next option under a one-tail test is that we have a right-tail test, okay? So option 2, which we'll call B, is that we have a right-tail test, and it's going to look like this right here. It's going to be like this. We're going to come in and we're going to say over here is a positive z. Again, this is my test statistic. I can spell that right. There we go. And that is going to be a z. And let's say that z in this case is 1.6. No, I don't want to use that number. I want to use 1.84. Okay? And it's a one-tailed test, in which case that tells me that this area under the curve is the area for my p-value right in here. So this is my p-value right in here. This is my p-value is right in there. And so another way of writing my p-value, mathematically speaking, is that it would look like this right here. I would say my p-value in this case is equal to the area under the curve, the probability that 1.84, let me do z instead, that z is greater than 1.84. It's going to be the probability that z is greater than 1.84, and it's going to be this area to the right. So in order for me to get that from our tables, it would actually be 1 minus, okay, the 1.84, the area under the curve, using our z tables. 1.84, so 1.84, 1.8, and then this is 0, 1, 2, 3, 4. So it is this number right here. 1.84 is 9671. So 9671. So 9671. So 0.9671 is this area right in here. And so this is going to be minus 0.9671. We're going to grab our calculator and I'm going to go 1 minus 0.9671, and that is equal to 0.0329. So that is the area under the curve right there. And so that is equal to 0.0329. And remember, your p-value, okay, this area under the curve plus this number here should always equal 1. So that's how we would get our p-value for a right-tailed test that is on the standard normal z distribution. Nathan, how are you? Whoops, I thought I was going back to the right screen. I'm not. Okay. I'm sorry if you've already answered this, but the exam is going to be multiple choice. I'll answer that after I get done talking with Nathan. Nathan, are you, so thank you, Ashley, for the question. Nathan, are you good with the right-tailed p-value? Okay, now, the next option is that you have a two-tailed test, okay? The two-tailed test up here looks like this with our p-value. If I have a two-tailed test, the difference is, that's a really sad looking graph. I'm sorry guys, my graphs are just looking sad right now. Okay, is that we may have a test statistic right over here, okay? It may be that we end up with a negative z for our test statistic. But because it's a two-tailed test, we have to divide our alpha into each end. Remember, if I have alpha is equal to 0.05 for my rejection area, I put half of 0.05 in here, so 0.025 over here, and I put a 0.025 in the right tail. It's the same thing for our p-value. We must double our p-value. So an easy shortcut, way of remembering is whether or not you have to double your p-value is based on how many tails you have. You can always just multiply it by the number of tails you have. If you have a one-tailed test, multiply the area you looked up by 1, and you're good. If it's a two-tailed test, multiply it by 2. Okay, so let's just say that our test statistic right here is, whoops, wrong color. Let's say our test statistic right here is negative 2.08. Okay, so that's going to be our test statistic. So when I look that up, I'm going to not only look in here, but I must also look over here. I normally just dot it in, so I know that it's not my actual test statistic. I'm going to put a positive 2.08. And then I'm also going to highlight this area over here. Remember, tomorrow have your crayons, your highlighters, your colored pencils, your colored pens, whatever it is that you need, okay? So for a two-tailed test, I'm going to look up, in this case, negative 2.08. And I'm going to come in here. 2.08 negative 2.0, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So that right there is the area under the curve between negative infinity and negative 2.08. So the area under the curve, oh, hold on a second, Jesse, hold on class, I'm sorry. Did you get the paint out of the truck? Did you see it?
Yes,
Okay, thank you.
I haven't painted it
No, I just wanted to let you know that paint's there.
yet. Taking me more than 15 to 20 minutes per frame.
Well, you may want to go ahead and paint because you need 2 coats of paint on, and that way you're drying in between, okay? Thanks, I love you. Appreciate it. Okay, so the area under the curve is 0.0188, so 0.0188. Whoops. 0.0188, and you have to double it because it's a two-tailed test. So the p-value is going to be equal to the probability that z is less than your negative test statistic, in this case negative 2.08, plus the probability that z is greater than positive 2.08, which is equal to 0.0188. Is that correct? Did I get that right? Yep. 0.0188 plus 0.0188, which is equal to 2 times, let's change that bracket, there we go, 0.0188, which is equal to 2 times 0.0188, 376. So 0.376. So that is our p-value for this two-tailed test. Therefore, my p-value is equal to 0.0376. Okay, so that is how we do the p-value for a z-test. Nathan, how are you? Nathan, are you there? Okay, so you're good with that right now? Do you want me to review how to do the t-test with the p-values? Or are you? I'm good now. Okay, in that case, we'll move on. Remember the t-tap values you have to interpolate. Okay, so Ashley, it is not a multiple choice test. You have to do all the work yourself and put in your answers. And then, like I said earlier, is you will email me a copy of your work within 15 minutes of the exam. I'm going to check out my cell phone real quick and see who's sent me a text. Okay, hold on. TJ, are you currently online? Okay, I've got a question from a student that's asking if they need anything else. You need to take that practice quiz. Let me text him that real quick. Has everybody online taken the practice quiz so far? You've got to make sure you take that to make sure your system is up and running properly. Okay, are we going to have to calculate X bar in some problems? Yes. You're going to have to calculate X bar. And I think, did I ask, good job everybody. Did I tell everybody that I was going to come back to number 12 in a bit, and I forgot to do that. So let me come back in for problem 12. Are you good? Okay. Oops. Time is going by too fast. Okay, number 12. Let me cut and paste it in. Jess, can you shut the door? I will take that as a no. Hold on, guys. I gotta shut a door. Oh, thank you. Okay, we're gonna start off with that screenshot. Okay, production quantities for 2 assembly line workers are shown. Each data value indicates the amount produced during a randomly selected 1-hour period. What is the point estimate for the difference between the mean hourly production rates of the 2 workers? Okay, this is probably very much similar to what you might expect on your exam tomorrow. So yes, this is small sample sizes for each. And so you're going to have to calculate X bar for both of these right here. So we're going to let worker 1 be population 1. So we're going to say population 1 is worker 1, I can do this. Worker 1, population 2 is worker 2. Okay, so now I need to take and have N sub 1, X bar sub 1, S sub 1, and I'm going to need the same thing for population 2. So N sub 2, I'm going to need X bar sub 2, and I'm going to need S sub 2. Okay, now, so I have 1, 2, 3, 4, 5. So both of these are sample size of 5. Let me come back over and look at the entire problem here real quick. Oops, right here. So production quantities for assembly line workers are shown. Each data value indicates the amount produced during a randomly selected 1-hour period. What is the point estimate between the production rates, develop a 90% confidence interval, consider confidence interval. And guys, I never did get to finish actually putting out a full review. And so I would expect similar questions like this concerning hypothesis testing too, just to kind of let you know that. I just didn't get to have a chance to get those concepts out on the review. So calculator, here we go. So there's our, we're going to turn on the calculator. I'm going to clear it out. I'm going to bring up my list. And I don't have anything in my list. If I did have something in my list, again, the shortcut way of deleting an entire list is you go up and you highlight the list, you hit clear, and then you hit enter. I see a lot of students that delete each individual X observation. You don't have time to do that, okay? So I'm going to enter this in. I'm going to enter in two lists. I'm going to go 20, enter 18, enter 21, enter 22, enter 20, enter. So that's that list in. Now I'm going to put in this list. 22, enter. 18, enter. 20, enter. 23, enter. 24, enter. Okay, now I have both lists entered in. So now I'm going to hit stats and I'm going to do some calculations. So I'm going to come over to calculate. I have two variables that I'm calculating. I need the X bar and the standard deviation for both lists. So that's equivalent to saying a two variable, okay? And so I can hit enter and it's going to say which list do I want. So the first list is X is going to be list 1. My Y is going to be X2. And I'm going to scroll down and hit calculate. Now I have X bar 1 right here. And then I also have my standard deviation, which is the 1.48323 for the standard deviation of population 1. And then I can scroll right down here and I can get the same information for population 2. So here's my X bar for population 2. Even though it's called Y, they just have to differentiate them, okay? It's really X bar 2. And then here's my standard deviation right here, the 2.4083 for population 2. So now that I have both of those pieces of information right there, I'm going to switch screens and enter that in just a second. So I'm going to move this right on over here. I'm live with my class, son. Thank you. And so X bar 1 is 2021 or 20.2 rather, excuse me. So it is 20.2. My standard deviation, I'm going to go to 4 decimal places. And it is this S, okay? You never need this sigma. You never need that sigma in my entire course for elements of statistics. If you take other courses, yes. But for elements of statistics, you won't ever use that. Okay, so it's 1.483 2. So it's 4832. 4832. 1.4832. And then I'm going to come in and get population 2. And I'm going to scroll down. And I have 21.4. 21.4. And then for population 2, it is 2.4083. 2.4083. 2.4083. And I know by now that I should come in and I should see my, when I hear beeping, it tells me. So how do we get the standard deviation without the calculator? How do we do this with just the TI-30XA? Okay, so here we go. Hold on, guys. I got this. Let me pause the video for just a second. Hey, guys. I need somebody to locate me a TI-30XA, please. I know I've got them around. If you could run that to me, sweetie, really quickly, I'd appreciate it. Meanwhile, I'll take a bite of lunch. Thanks, honey. I need the 30XA. Thanks, honey. That's what I need, honey. Are you live? I am. Thank you, honey. Okay, so let me do it like this. Come on. Da, 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 Let's see here. Insert. Actually, let me do it this way, guys. Yes, you may. Just don't take it away. No. Oh, you need a finger? Just don't connect to the Wi-Fi. You can hotspot off my phone, but don't connect to the Wi-Fi because I need it for the class here. Okay, here we go. Alrighty. So, so here's our data set. So everybody who has a TI-30XA, turn on your calculators, hit enter, make sure you see a 0 there. And the next thing you're going to want to do is you're going to want to hit your second button. Let me change my color of my mouse to red. There, now you can see it. My second button and then 7, okay? And you want to do that until you see the message error, ERROR, okay? So you hit second and then the number 7. That clears out your list, okay? And I'm going to continue giving instruction. If you have the TI-30XA and you need me to, if you need to interact with me, if you have a microphone, just go live, okay? So the way you're going to enter your data, we're going to do it one at a time. So we're going to take 20. So once you have the error, just hit clear, okay? So hit 20, and then once you put 20, don't hit this sigma plus sign right here, okay? The fourth button down on the left, right here. Hit that, and when you hit that, it should say n equals 1, okay? Then you're going to hit 18, and you're going to do the exact same thing. You're going to hit that sigma button again, and then now you're going to see n equals 2. Now you're going to hit 21, and you're going to hit that button again. 22, hit that button. 20, hit the button, and it should say n equals 5. Does everybody who has the 30XA have your data entered into your list right now? Oh, did I not scroll? The TI-30XS, I don't recommend that calculator, so I don't know how to use that one. I have the 30XA. Bill, do you have the 30XS over there? Oh, he went outside? Hold on, my husband might have that one. If he has it, then I'll see if I can figure it out. Bill, do you have the 30XS? Or which one is it that you have? Hold it well. There you go. Okay, so, okay, Ashley, is that the 30XS?
Mm-hmm.
Do you know how to do statistics on this one?
That's the same as the other. Let's see.
Where? I don't see where you insert your list, honey. Oh, it's under data? Okay, how do you clear a list out? And then how do you retrieve the mean and the standard deviation? Okay, I'm going to let my husband look at that calculator for just a second on the TI-30XS, and I'm going to continue answering about the 30XA. Okay, Tim, I can't right now. I'm sorry.
I said you need it. I thought you
No,
wanted
I need it to sit here for texting purposes. I need to be able to check for text, okay? Okay, so back over here. Here we go. Okay, so assuming that you have your list in, now the next thing you're going to do is you're going to hit your second and then your x squared button. So you're going to come in here, you're going to hit your second and your x squared button. That gives you your x bar, okay? Then you're going to hit your second and this button right here, and that's going to give you your sample standard deviation, okay? So you should be able to do that and get the 1.483 whatever. You're just going to have to then clear out your list again by hitting second and then the 7, and then re-enter worker 2 and get the same information out from worker 2. So, Ashley, it looks like you have the 30XA, is that correct? Okay, so were you able to get the sample mean and the sample standard deviation quickly out of your TIX? Okay, great. My husband's still working on the other.
Oh, okay.
Oh, you got it? Oh, okay, then show me how to do it.
basically when you had lists, you just hit the delete and it clears it. So
Okay.
you put your list in and all that stuff, and then when you go second stat, then you've got the 3 different things.
And
you
you
can
hit
do.
enter.
And you just, whichever particular one you're working with, yeah, and you hit enter, and it gives you all your basic or descriptive
Okay,
statistics.
so how do I clear out a list? I hit data, and okay, I see that.
Yeah,
Okay.
and then delete will clear the list.
Okay, so here's the TI-30XA, or XS, the TI-30XS, okay? Ying, I already did the TI-84 on the computer screen for everybody, okay? And I can help you out with that in just a second. Okay, so here's the TI-30XS. I've got one in my hands. So you're gonna hit data, and you should see empty list, okay? So once you have that, let me come down and get the data. So we should be able to hit 20, and then and then you use the arrow button to move down to 18, move down, 21, move down, 22, arrow button to move down, and then 20. And do I hit enter? I do, okay. Or I guess you can hit enter on all of those. So then you're going to scroll over to list 2, and you're going to put in worker 2. So you're going to hit 22, enter, 18, enter, 20, enter, 23, enter, 24, enter. And let me make sure I'm still recording. I want to make sure I am recording this. Yeah, I am. Good. And then once you have those data lists in, you're going to hit the second button and then the data button again, because that brings up the statistics. Then use your mouse to cursor down, or your mouse, your arrow buttons to go down to 2-bar stats and hit enter. And then mine came up identifying X data as list 1, Y data as list 2, which I'm good with. And then I'm going to hit calculate. And when I did that, it came up with X bar 1 equaling 20.2. The very next thing after the X bar 1 is my sample standard deviation of 1.4832399697. And then, how do I scroll? You have to press down pretty hard. At least on mine, this one. And then I get Y bar, which is 21.4. And then my sample standard deviation for population 2 of 2.408318916. Okay, so that covered the TI-30XA, the TI-30XS, and you're welcome, Mallory, and the TI-84. So is everybody set on their calculators and the shortcuts? Can you show how to enter the numbers on the list again on the TI-84? Yes, Peyton and Ying, do you have your calculators handy right now? Ying? Okay, here we go. So we're going to bring up the calculator, and this one here will have a list. It'll have numbers in it now. Okay, so hit stat and then hit your enter button, and that brings up your list. Okay, I'm going to clear out both my lists and start from scratch. So to clear out my list in one, whoosh, like that, you highlight the list, you hit clear, then you hit enter. If my mouse will move, please move down, enter, and then you can go over, and now you highlight list 1, hit clear, and then hit enter, and now both my lists are cleared out. So again, to get to this part here, you hit stat, and then you hit enter, and that's how you bring up the list. So for list 1, I'm going to enter in 20. So I'm going to come over here, I'm going to hit 20, and then enter. I'm going to put 18, and then enter. I'm going to put 21, and then enter. 22, and then enter. 20, and then enter. I'm going to scroll over by hitting my cursor button over here to list 2, and now I'm going to put in 22, enter. 18, enter. 20, enter. 23, enter. 24, enter. Okay, now I have the data, the raw data put in for both of those. So now I'm going to hit stat again, and I'm going to do some calculations, and I'm going to do 2 variables. So I'm going to scroll down one time to right here, so I have 2 variables highlighted, and then I'm going to hit enter. and it's going to say, do I want my X list to be list 1 and do I want my Y value to be X2? I'm going to say yes. So, but you can change that, okay? So make sure if you have list 3, 4, whatever, you change it according to where you have your data. And then I'm going to come down to calculate. I'm going to hit enter. And now I have X bar. And then this one right here, the S is my sample standard deviation for my worker 1. And then I scroll down and here is my Y bar, or my, really, it says Y bar, but it's X bar sub 2. And then here's my sample standard deviation for population 2 right here. Okay, I heard somebody coming in, and you're welcome. Okay, now let me show you something else. Since we're here, we're not quite finished with this thing, but for the people who have the TI-84, okay, let's say hypothetically speaking, I wanted to do a confidence interval just on list 1, okay? So I could hit stat. And since I don't have summary statistics, I've got a confidence. I want to do a test, okay? And I could come down here to number 8, I think it is. Yeah, number 8. And this is a T interval, okay? Because I don't have my population standard deviation. I have a sample standard deviation. It would be a T test, okay? And let's say I just want to do it on data 1. So I'm doing a T hypothesis test with raw data, and my data is in list 1. Okay, actually, I'm sorry, this one here is a confidence interval. I'm doing a confidence interval, sorry. This is a confidence interval for T. Okay, so I come down, I highlight that, and I say this is what I want, and it's going to ask me 2 questions. It says, did I put in the data, or am I putting in summary statistics? In this case, I'm putting in raw data. And the raw data is listed in list 1. So I'm putting in data in list 1. And let's say I wanted it at a 95% confidence level. Oh, well, let's go ahead and show you can change that, okay? So let's say I want it at 90%. So I change that to 90%. And then I can scroll down and I can hit calculate. And it's going to give me my confidence interval. It does not give me my E, okay? You're going to have to know how to calculate E, and yes, you could get it from this, but I'm not telling you how to do that, okay? But there's your confidence interval, okay? There's your X bar, there's your sample standard deviation, and there's your sample size, okay? So that would be how you could do a quick confidence interval. Same thing if you were going to do a hypothesis test. You could hit stat, come over to test. I'm going to do a hypothesis test right here. And I'm going to use data, and let's say I wanted to see if my mean is different than 20. Let's just say I wanted to see if it was different than 20. Okay, and I would say my data is in list 1, and let's say I wanted it to be different, therefore it's a 2-tell test, and then I want it to calculate. I don't want it to draw it, I just want it to calculate it, and there it would give me my critical or my test statistic and my p-value, okay? It does not give you your critical value. You have to look that up on your own, but it does give you your test statistic, and it does give you your p-value, okay? So normally I don't give that information out until after this exam coming into the final. I have several YouTubes on how to do all of these shortcuts, but since this is kind of hopefully your final, I'm giving you this information. I do not know how to do the Casio. If you can send me a picture of it, text me a picture of it, Jason. My husband may know how to do the Casio, or I might be able to figure it out. You may have to just YouTube it. But no, I don't know how to do the Casio. Should I even ask how that happened?
I don't even know.
I love you. Okay, so here we go. Now let's finish this problem right on up. Alrighty. So it says, what is the point estimate? So the point estimate, we're doing the difference. So here's our point estimate. Getting back to the problem at hand is this. So our point estimate, oops, sorry about that. That was my fork. Okay, so our point estimate is going to be X bar 1 minus X bar 2, which is 20.2 minus 21.4. So it looks like a negative 1.2, but I'm going to punch it in my calculator just to make sure my brain is not teasing with me. 20.2 minus 21.4, negative 1.2. Very good. Is he going turkey hunting or something? Negative 1.2. Okay. And then that was part A. The next part is develop a 90% confidence interval for the difference of the means of the two production rates. So it is a t-test. So I need a critical, did it say 90%? Let me double check my alpha level on that. 90%. Okay. So let me write that down. So I'm looking for a 90% CI. So I need to calculate my E. My E is going to be equal to T with whatever my degrees of freedom is, and then 0.10 times the square root of S squared divided by N plus, that would be population 1, population 2, N1, N2. I will double check that against my formula sheet because sometimes my brain does not work right. It has a faulty memory at times. Hypothesis testing, confidence interval, difference, right there it is. Okay, very good. Okay, so here we go. Degrees of freedom is going to be 4 because the sample sizes are the same. So my T4, 0.10 is equal to, let's look that up, right there. Okay, so 4 degrees of freedom, coming all the way over to right here, it's 2.132, 2.132, 2.132. 2.132 is my critical value. So right here it's going to be 2.132 times the square root of population 1 is 1.4832 divided by 5, that's squared, plus 2.4083 squared divided by 5. And I'm going to get E is equal to, let's grab the calculator. Let's double check, make sure nobody's saying something. Why did I use 0.1? Because I'm doing a 90% confidence interval. So, oh, your table's due by 0.9. Sorry. Sorry. The standard tables, the standard T tables would actually just have these values up here. So sorry about that. Since UWF did the math, it's 0.9. Sorry, I forget that they put 0.9 and not 0.1. So because I listed my alpha, Mallory is what I did, instead of listing the confidence coefficient, which is what you guys have. So that should be 0.9. Sorry. There we go. So let me go back and look at what the value is. And let me erase it over here real quick. Old habits die hard. So 0.90. I'm used to just always working off of alpha or half alpha. So it's, whoops, wrong table. So it's 2.132. So 2.132. Okay, and whoops, I didn't need to write that there. That was E. Okay, I'm hearing more bleeping, so let me come in and check before I bring up the calculator. It should be squared. Did I not write down a squared there? It's got a square right there. Can you see the square right there? So it's 2.4083. So hold on. Why did I use 0.1? I answered that. How did I get the sample standard deviation S1? S1 I got from the calculator. Isn't it 1 point? Did I write something in wrong? The first S. Did I write it in wrong, Rowan? Is that what you're saying? Did I just copy it down wrong? 1.8. Oh, 4.8. Oh, my calculator dropped the 4. When my calculator gets, or when my computer gets hot, it drops what it considers to be insignificant marks. And that mark right there, it considered it to be insignificant. So it drops negatives, it drops the crosses of my addition signs, it drops, yeah, so sorry about that. Yeah, it's 1.4832 and then 2.4083 and then that number there. So yeah, thank you so much. Okay, so we're gonna turn this on and I'm gonna drag it over here and hit clear, and I'm gonna go 2.132 times the square root of parentheses 1.4832. If you use the squared button like that, you don't have to move your mouse down. If you don't, I'll show you how you do it on the next one. So then it's plus, open parentheses, 2.4083. If you use the caret button and you put a 2 there, you now have to take your mouse right here and move down, okay? And put your divide and 5, close parentheses, and come out from underneath it and hit enter. So my test, or my test statistic is 2.697, 2.697. 2.697, not test statistic E, sorry, margin of error. So for my confidence interval, my CI, it is going to be negative 1.2 plus or minus 2.697. I can already tell that's not going to be a significant test. It's going to include the interval 0. So negative 1.2 minus 2.697, and I get negative 3.897. I'm going to go up and highlight, hit enter, go back and change that to a positive addition, and it's 1.497. And I should do that in case I have new students that have not seen this. Let me show you this other shortcut also on the TI-84. And so if I come in and I go like negative 1.2 subtract 2.697, hit enter, that's going to give me my lower bound right there. To get my upper bound, I can just go up and highlight that equation and hit enter. It brings it right back down. Now I can hit this button right here to the left, change that subtraction into an addition, hit enter, and now that gives me my upper bound. And that is on the difference of the means. I don't think the TI-84 calculates this correctly on the confidence intervals. Let's go look. If I want to do a test, I want it to be a confidence interval of the difference of means. I don't think, yeah, we don't have, it does not do the difference of means on the confidence intervals. So I don't think that this is it. Well, this is 2 sample. So let's look at this and see if this does it or not. Let's hit enter. We're going to do data. It's going to be list 1, list 2. Level of confidence is 0.9. I think it doesn't do it because of the pooled. Let's just see. I don't know if this is a confidence interval or if this is, so negative 3. Yeah, see, it's not going to calculate it out properly. Let's change the data real quick and let's just see if we change it to pooled. I don't think, if I remember correctly, the TI-84 does not calculate this correctly. Let's do yes. And then hit enter and then calculate. Yeah, you cannot use the TI-84 to get the difference like this right here. Okay, you can't use the shortcut. So if you were thinking about doing that, please don't do that because you will get the wrong answer. Okay, it does not handle this calculation the same. Okay, it uses a different formula and it does not use the same numbers and everything. So, so do not use that. Alrighty, let's look at other questions that we may have. Any other questions right now? Let me look, see if anybody's texted me. Bill, are you in the house, honey?
What?
Is your dad in the house?
No.
Okay. Let's see here. Whoever texted me that one picture of the calculator, when my husband comes back in, I will have him look at it and have him text you back. Okay, so I'll get him to help you with that if he's able to. He's typically pretty good. Okay, other questions? Other questions? Okay, so let me go over what you can expect on the exam. Okay, so let me bring up the review. And you can expect to see probably, come on please. You can expect to see probably about 75% of the problems you've had access to, okay? What that means is between your homework and the review and any supplemental exercises that I may have just thrown out there at you, you will probably see 75 to 80% of the test already, okay? With the majority of that coming from the review and the homework, okay? 20% will be material you've not seen before, okay? Where the others will be very, very similar to what you've seen. Different numbers. If there was a Walmart, it'll be changed to Kmart. If there was a Burger King, it might be McD's. But very similar. I'm not going to be able to have you draw a picture. That's not going to be a concept that I can have you do. However, show your work, draw your pictures on your paper that you send to me. I can still have you calculate the probabilities and do things of, I've already worked all that out where you can do the probabilities and things of that nature, okay? Calculate your z-values, calculate your x values, what your x values would have to be. Make sure that you remember that all of, like, problem 1, 2, 3, 4, 5, and 5. Okay, so 1 through 5 all have to do with an individual X observation. Okay, once you get to number 6, the only difference between number 5 and 6 is our sample size. For number 5, sample size is 1. We have one individual that we're saying if one person is selected at random, what's the probability that this person's drive to work will be between these values? The only difference here is this one here has 10, so my Z, the way you calculate your Z, has changed. Remember the denominator for problem 6 is now going to be your sample standard deviation divided by the square root of n, okay? Divided by the square root of n. So make sure you connect the dots on this change. Expect something very similar to this on your exam tomorrow as well as your final exam. A random sample of 50 students, point estimate, so that's a confidence interval. And then also combined, that's a confidence interval. Number 9 is a hypothesis test. Then this one here is another hypothesis test. This one here is confidence intervals difference. Another confidence interval, which this could easily go right into a hypothesis test with the difference of means, and you'd have to calculate all that with raw data. And then this one here is proportion. So this is going to be a Z, and this is a hypothesis test. The only other thing that concept that wasn't directly presented is if I gave you a proportion. Let's come back here to this question right here. Instead of giving you the summary statistics, I could have had something where your sample size was maybe 10 and 15, okay, as opposed to 16, 80. And then I could answer the question, did it default or did it not? So it would be a yes, no, okay? Yes, if it defaulted, it would be one of the 9 or one of the 6, okay? And you can manually count that. You can count how many yeses and how many no's there are so you can get your own X's and your own proportion, okay? Where X is what satisfies the question being asked, okay? So make sure you're ready for that. If I asked you to do something at the 96th percentile or a hypothesis test and it's a Z, okay, if I asked you for 96 and it is a one-tailed test, so one-tailed test, so if it's a one-tail, and I want alpha to be equal to 0.04, and I'm going to make it a left tail, okay, it's going to look like this. You need to find your critical value, and 0.04 is going to go right in there. So your critical value, everybody grab your z-tables and look that up on your own real quick. It would be this value right here, right? Negative 1.75. So negative 1.75 would be the closest value that I have to 0.04. So that's negative 1.75. So it would be equal to negative 1.75. If I had a two-tailed test, and I said alpha is equal to 0.04, my picture would look like this. And again, remember, I have to put half of alpha in this area, so that's 0.02, and I have to put half of alpha in this one, 0.02, and so my critical value would be something along the lines I would choose this value right here, negative 2.05, negative 2.05 right there, because that would be half of alpha, so negative 2.05, negative 2.05, and then positive 2.05, okay? Make sure you know how to get those unique critical values. When I say, you know, I want you to calculate a 93.78 confidence interval, okay? If it's something weird like that, chances are it's going to work very nicely into a very exact value. Remember your confidence intervals, you use half alpha, not whole alpha. I heard a question come in, I think. Yes, Alex, you always round up on n, unless it's a whole number. If it's a whole number, then it's whatever that whole number is. Very good question, because you will have questions like that. So going back to the review, yeah, sample sizes are something that you're going to have to know how to calculate for certain either hypothesis test or for the confidence intervals, okay? So other questions, guys, this is your time. We've got about 14 minutes left, and my voice is starting to give out, as you can hear. So any other questions? I just got a text from my mom. There's a snowstorm in Denver right now. She sent a picture. So you can call her after I'm off work. I'm still talking to my students. Yes, I am. Any other questions, class? If not, we're just going to go ahead and end early. Any other questions? Okay, so are you guys good with ending early? A few minutes early? Number 13 on the review, or for what, Rowan? The review, okay. Here we go. Okay, here we go. So we have, let me grab my stylus. So we have 2 loan officers in the Northridge National Bank show the following data for defaults on loans that they have approved using alpha is equal to, so there's one of those strange alpha numbers right there. 0.0118. Test the hypothesis that the default rates are different for the 2 loan officers. What is the p-value? Love this question. Okay, here we go. So our hypothesis test look like this. We have H naught, H1, and we're doing proportion because we're looking at rates. So when you see the word rate, that clues you in that you are looking for a proportion. So that is proportion. Okay, and we're looking to see if they're different. So I could say that P1 does not equal P2, and P1 equals P2, or P1 minus P2 equals 0, or P1 minus P2 does not equal 0. Okay, either one of those scenarios gets you 100%, but don't mix and match. You have to have it written like this or like this. Okay, so my alpha value is well, let's see here. So in 1, I'm going to let population 1 be officer A. I'm going to let population 2 be officer B. So N1 is equal to 60 because he processed 60 loans. Of those, 9 of them defaulted. Okay, and then N2 is 80, and X sub 2 is 6 because 6 of those defaulted. So let's draw a picture of what we're looking for right here. We are doing a hypothesis test. It is a 2-tailed test, and I need to know what my critical z-values are. I'm going to be putting half of alpha over here. I'm going to be putting the other half of alpha over here. So I'm going to put 0.0118 divided by 2 in here, and 0.0118 divided by 2 in there. And so I'm grabbing my calculator, and I'm going to go 0.0118 divided by 2 is 0.0059. So 0.0059, 0.0059. This is going to be my fail to reject area, and that is going to be green. Did I grab green? I did. And then over here is my reject, right in there, and over here. And now what I need to know is what are my negative Z star and what is my positive Z star. Those are my critical values. You know, you draw the line in the sand. If you cross over, you're in trouble. That's kind of concept here. We're not going to get in trouble, but we're looking for the line in the sand. So 0.0059 is what I'm going to look up in my Z. So 0.0059, right there it is. Okay, 0.0059. So my negative Z value is negative 2.2. So negative 2.2 right there. So negative 2.2. No. Let's try that again. Negative 2.52. There we go. Is negative 2.52 and then positive 2.52. So Z star is plus and minus 2.52. Does everybody understand how I got that critical value? That's the first thing I really want to make sure. Is everybody good up to this point? Jason, it was provided in the problem. Very good. Okay, so in the problem, Jason, it said right here, it says using alpha is equal to 0.0118. So that's where I got that from. Okay, very good. Okay. So coming back over, so that's my picture. Now the next thing I have to do is calculate my test statistic t. So we're going to come in here and let's see here. Actually, let me do this right here. We're going to put our test statistic, and let me find the come on, proportion right there. So there's our test statistic, and we're going to insert that in right here. Insert a screen clipping right there. There we go. Okay. So my Z, hold it. I'm doing two proportions, aren't I? Sorry guys, hold on. Let me go back and grab the right formula. I just realized I'm doing the two proportions. I am. Okay, let's try that again. Okay, so let's come back down here, make sure it's in my view. It's going to be this one right here. So two proportions. Insert screen clipping. Here we go. So it's going to be that one right there is where my test statistic comes from. So p hat 1 is going to be p hat 1 is equal to 9 divided by 60. P hat 2 is going to be equal to 6 divided by 80. We're going to say that the difference is 0. Let's see, or p bar. I need to calculate my p bar rather. It's going to be next. So p bar is going to be equal to x sub 1 plus x sub 2 divided by n sub 1 plus n sub 2. So this is 6 plus 9 or 9 plus 6. Let's go back up here. It's 9 plus 6. So it's 9 plus 6 divided by 60 plus 80. So let's double check that. 9 and 6, 60 and 80. We're going to throw that in our calculator, and I'm going to get 0.1071429. 1, 2, 3, 4, 5, 6. I went to 7 decimal places. Always go to 6 because proportion is highly sensitive to rounding errors. It's highly sensitive to rounding errors. And if you're having problems on problem number 8 and number 10 maybe, on mod 8, it's because you're not using the ratio. You're using what they accepted as the correct answer in part A. You need to use the actual figures and the ratios to get the correct answer. So it's going to be 90 divided by 60 plus 6 divided by 80, all divided by the square root of p bar, which is this number right here. So it's 0. Do you need a finger? You're welcome, sweetie. 1071429. 1071429 times q bar. Q bar is 1 minus 0.10711429 times 1 over 60 plus 1 over 80. I hope I have those in the right order. All of that's underneath the square root, and all of that is in the denominator. Okay, so we're going to put this in our calculator, and we're going to find out that, yes you may. So it looks like this right here. We're going to come in and clear. So do double opening of parentheses, overuse parentheses. You've heard me say that before. You're going to want to do that now. So it's 9 divided by 60, close parentheses. That's one fraction. Plus open parentheses, 6 divided by 80.
Shouldn't it be a subtraction?
Oh, high five. I think it is, isn't it? It is. Who in the world said that? Thank you so much.
No problem.
Boy, thank you. I'm tired. If you can't tell, I'm tired. I'm sorry. Yes, thank you so much. Okay, so let's come in here. Eraser is what I need. There we go. Thank you very much. Okay, so subtraction. There we go. Is everything else right now? Yep, okay. So back to the calculator. Okay, so clear. Double parentheses. 9 divided by 60, close parentheses, minus, open parentheses, 6 divided by 80, close parentheses, okay? Divided by, open parentheses. I'm just doing that just because you can let the square root count as your parentheses, and that's fine. But I went ahead and threw it in parentheses. Okay, so it's going to be 0.10711429 times parentheses 1 minus 0.1071429 close parentheses times open parentheses 1 divided by 60 close parentheses plus open parentheses 1 divided by 80. That did not come in there right. Let's get that taken care of. 1 divided by 80 close parentheses come out close parentheses equals. Whew. Okay, 1.4199. So 1.4199. So 41.99. 41.99. So Z is equal to 1.4199. I'm going to double check that to make sure. Or was it 40.99? 41.99. There we go. So this is equals, don't drop, and so this is going to be 1.4199. I failed to reject my null hypothesis. There's not enough statistical evidence to declare that there is a difference between the population proportions between worker 1 and worker 2. Yes, Jessica. H naught is our historical data. That's what we have historically known to be true, or what we've historically claimed to be true. H1 is what we're testing. That's what we're trying to substantiate. Can I say that H naught has either changed or that the people, depending on the situation, are not being truthful? But you can only do that if you have a significant statistical difference. Very good. Is everybody else ready? No, Jason, it's not, but good try. I've given a lot of partial credit away already for earning it. What was the final answer? The final answer is that we failed to reject Ashley. So our test statistic was this right here. We came back up and plotted it right here, and our test statistic landed in the fail to reject. Oh, we got to do p-value, right? So let's do our p-value. So our p-value is going to actually be calculated off of 1.42. If you look at that, it's going to be 1.42. Excuse me, and it's a two-tailed test. So for our p-value, let me come in here and get some purple going on here. So for our p-value, it's going to be right here, and it's going to be right over here, and that's going to be 1.42 is what I'm actually going to look up for my p-value, because that's what that would round off to, and that would be a negative 1.42 over here. So I need to come in and, let's see here, my p-value. My p-value, because you always state that, is, it's going to be 2 times the area under the curve from negative infinity to negative 1.42. So all I have to do is look up negative 1.42, take that area under the curve and multiply it by 2. So in here, that's my z, negative 1.42, negative 1.4012. So it's 0.0778. 0.0778. 0.0778. Throw that in our calculator, and my p-value then is 2 times 0.0778, and that is 0.1556. So I failed to reject my null hypothesis. My test statistic is 1.42, 1.4199, which falls in the failed to reject region of my picture. Okay, or I could compare my p-value to my alpha. Okay, my alpha is right here, my p-value is right here, and since my p-value is greater than my alpha, I also failed to reject my null hypothesis, and in your conclusion you would state your p-value. I will, on your conclusions, try to do like web work and do the either or. Okay, any other questions, guys? It is 34 after. I've not eaten breakfast, nor I got 3 bites, I think, of my lunch down, and that was it. So I think I'm ready to sign off yet. Is everybody good? You are more than welcome. I have not quite finished making your exam yet. So, I'll be probably up working a little bit later tonight. If you have questions, just send me an email. I may just say, can I call you? Because it might be faster for me to call you. So just let me know if that's an option or not. And remember tomorrow to take pictures of your work. Send it to me within 15 minutes of you submitting your exam. Just take your time. You're going to do great. I'm very proud of each of you guys. And thank you so much for joining me and coming to the study sessions. Very proud of all of you, and I've so enjoyed having everybody in my class. I hope all of you make an A, and that you have an A in the class, and that you end up being exempt from the final, or that you just decide that you're happy with your grade. So, but if you have any questions, just holler at me, okay? And if you do have accommodations, please let me know if your accommodations are 1.5 or 2, and so that I can adjust your time settings, okay? So you'll have a good day, and I'll talk to y'all later. I will render this video. It takes twice as long. This is a 2-hour video. It takes twice as long as it is to render it, so it's a 4-hour process. And then because I have to hotspot to upload from my home, it takes probably another 1.5 to 2 hours. So this video will not be available probably, what time is it? 4, 7, 9, till about 9 o'clock tonight. I will get it uploaded as fast as I can, but don't look for it as something soon, because it's not a quick, fast process, okay? You all take care, and if there's any problems or anything, I'll work with you tomorrow, okay? So just don't panic, okay? Talk to you all later. Bye-bye. Thank you. Thank you.